Alright guys, so what we're going to do now is put these Euler circuits into an application. Alright, and one of them is like a Mr. Plow, but this can apply to any situation like trash pickup, delivering mail, bus routes, things like that. So with a plow, you're trying to clear a road of snow, right? And you want to do this efficiently as possible without having to backtrack is the idea here. Alright, so and here it explains here, so as a new snowplow operator, you must decide the best route through 3 cities. Each city you need to plow all the roads and return to your starting place. Okay, so you got to create a circuit. All right, what do you, but you also keep from backtracking as much as possible. So if you can't do an Euler circuit, then you're going to have to backtrack on some of these roads, all right? So um, you have to look at the paths wisely here. We're going to construct 2 snowplow routes through each of the following cities. Okay, so we got city 1, 2, and 3. You'll have these on separate slides. And we need to record the time it takes to traverse each road in hours as indicated in the graph. So this is a whole thing on something called weighted graphs. All right, so the numbers mean something. So this is a representation of a city, okay? It doesn't mean the roads look like this. This is an organizational tool, okay? And there's many applications for this. All right, so take for instance the route from A to B. All right, this road here is gonna take us 3 hours to plow through it. All right, B to D will take us 2 hours. All right, so we want to keep those weights in mind, okay? And just because it's a smaller road, so if you look at the segment B to C, that's 7 hours, and B to E appears to be a longer road, that means nothing here. Okay, the time is what's important. So all we're doing is we're just basically connecting dots. Okay, and again, it's just an organizational tool. The length of the edge doesn't mean really anything. All right, the numbers are what we're looking at, and these are the time it takes to clear the road in hours. Okay, so what we're going to do is we're going to put some paths through here. All right, so one possible path we can do is label this path 1. All right, and instead of drawing a bunch of arrows through here, what I'm going to do is I'm going to label the letters, the vertices, okay, so they'll know which way we're going. So you can draw on here. I've made the draw it slide, so if you want to kind of chart out a path and then erase it, but record it over here. The text tool may be more helpful here than trying to draw with your finger or stylus, or if you have a really accurate smart stylus like my Samsung tablet or iPad Pro or even a Surface tablet. Those are really accurate and you can do like all the things I'm doing here. But use the text feature and that'll help you out. All right, so this possible path. So let's say I'm going to take A to B. All right. And then from B, I'm going to go to C. All right, so let's just look at those first 3 letters I put there. Basically what that means is I went A to B and then B to C. Okay, and then you just keep going to the next letter and that tells me which direction I go. So from C, I went to E and that way. Okay, so I'm not going to draw any more arrows just so you understand how the path works there. And that's what you're going to be doing on your other cities. And actually, you're going to do the second path on this one. Each city wants 2 paths. All right, and I'll explain a little more. All right, so this is the path that I found. So we got E to D, D to F, back to E, B, D, B, C, and then A. All right, and as I'm doing that, I'm adding up the hours. So you may have to have a calculator on your side, then calculate your cell phone or something, and then just type in these hours as you go. So from A to B is 3 hours, B to C was 7, that's 10 hours right there. C to E is 13 hours. So when I total all this up, this is going to be 46 hours. All right, now you're going to come up with path 2. All right, you're going to do 2 for each one. And what you want to do is try to beat your initial path, okay? So my first path plows all the roads, and I end up back where I started. So I end up back at A. So this is where I start and finished right there. I'm going to tell you right now, on City 1, it is possible to get a smaller time than 46. All right, the rest I'll let you kind of figure out there. Okay, you may be able to do it, you may not be able to do it. All right, now on this one, I did do some backtracking, so you want to like look at this. Am I going to have to backtrack? So if you remember back to the lesson with Euler circuits, that you will get all the edges exactly once and end up back where you started. Okay, And the way we figure that out is the degrees. All the vertices had to have a degree, an even degree. Okay, so B has a degree, I'm going to put D4, degree of 4. D has a degree of degree 3. All right, so again, it's just a number of edges that connect that point. All right, so if we have an odd edge in there, okay, we know right off that it's not going to be a circuit. So we're going to have to backtrack somewhere to end up where we get back. So it didn't say we couldn't not backtrack. We want to do it as efficiently as possible. But we do need to finish where we started, because we got to, if you think about the plow, you leave the garage, you're going to pick up the plow, you know, plow the streets, that's your day job, and then you got to come back to work, clock out, go home. All right, so give this a try. Be sure that you're hitting that submit button on the drawing, otherwise I won't see what you wrote on the Nearpod. So once you're done doing your thing, press submit, go to the next slide.